Hello everyone. So we are going to solve this problem related to the mass attached to a spring. So let's say this mass is attached to a spring, and the position of this mass is given by this function. Okay, and when we drop this mass, then when t tends to infinity, this mass attains a stationary position, and that position we call it equilibrium position. Let's say if we drop this mass and it comes to rest as t tends to infinity here, then this is the equilibrium position, and we call this position u equals to 0. Then if we have u equals to 2, that means we are 2 units down the equilibrium position, and if we have u equals to -1, then we are 1 unit above the equilibrium position. Okay, so every distance will be measured from this position. Down means positive and up means negative. Okay, now the position of this mass is given by this function. Now we have to tell about the following questions. Which direction the mass is moving initially? So initially t is equals to 0. So if we put t is equals to 0, then u of 0 will be 3 plus 1, it will be 4. So that means we are starting 4 units down the equilibrium point. Okay, if this is the equilibrium point, then we are starting here, okay, at u equals to 4. So that means if we drop this mass here, since we are below the equilibrium point, if we release the mass here, then it will go up. Okay, so initially the mass will go towards the equilibrium position. So which direction the mass will move initially? In upward direction. So this is the answer to the first part, that mass will move upward. Okay, and how can we verify that? How can we verify that from the function? That is just by intuition. But how can we verify it mathematically? So for that we have to take the derivative of this function u dash t. It will be minus 12 e power minus 40 minus e power minus t. Now if we calculate u dash 0 is equals to minus 13. That means u is decreasing at t is equals to 0, and if u decrease, then mass will go up. Okay, mass will go up. Why is that? Because positive value of u represents position below the equilibrium position. So if u decreases, then mass will go up. If u increases, the mass will go down. So since u dash 0 is negative and u is decreasing at t is equals to 0, that means initially at t is equals to 0, the mass will go in upward direction. Okay. Now the second is, does the mass ever go through the equilibrium position? Okay, so we know that if t tends to infinity, the mass will go to the equilibrium position. That we can simply check by, if we take t tends to infinity in u of t, then we have 0, because this term will tend to 0 and this term will also tend to 0. So it go through the equilibrium position when t tends to infinity, but does it go through the equilibrium position for finite t? That we have to check. Okay, for finite t. So for that we will put the position function equal to 0. So u of t equals to 0, and then we try to find the finite values of t. Okay, so if we do that, e of 3 e power minus 4t plus e power minus t equals to 0, and if I take e power minus 4t common, then I will have 3 plus e power 3t is equals to 0. Since this cannot be 0, so this has to be 0. So 3 plus e power 3t is equals to 0, and e power 3t equals to minus 3. And this is not possible because exponential function is never negative. Okay, this is not possible for any value of t. For any value of t, this is not possible. Hence, there is no t for which this function is 0. There is no finite t. That means the mass never goes through the equilibrium position in finite time. It never goes through. Okay. So answer to the second question is no. It does not go through the equilibrium position ever. Now the final question. The final question says how low does the mass get? How low? Okay. So let's try to see this. Now we are starting. See, we are starting at x equals to 4. Let's say this is the equilibrium position. This is at x equals to 0, and we are starting at x equals to 4. And when we release it, it will go up, and it will keep on going up. Okay, as t tends to infinity, it will keep on going up. It is not oscillating, or it is not coming back. It is just keep on going up. Okay. So what is it asking? How low does the mass get? So the maximum low is the initial stage, because it is not coming back. Okay. So the maximum low the mass will have is the initial stage. So x equals to 4 is the maximum low the mass will get. Okay. So all of the parts we can answer by just analyzing the position function and understanding the process. Okay. So that's it for this video, and thank you for watching.